matters steps to design a cache system. Designing a cache system involves several steps to ensure it improves performance, scales effectively, and aligns with the application's requirements. Here's a broader step-by-step approach. 1. Define the goals and requirements. Understand the purpose. Identify why caching is needed, e.g., reduce latency, decrease database load, handle high traffic. Determine data characteristics. Analyze the data being cached, size and structure of data, frequency of access, hot versus cold data, volatility of data, how often it changes. Set constraints. Define latency requirements, storage capacity, and cost considerations. 2. Choose the cache storage type. In-memory cache, used for high-speed access, e.g. Redis, memcached. Disk-based cache, used when large datasets need to be cached but with slower access, e.g. SSD-based caching. Hybrid, combine in-memory and disk-based caching for a balance between speed and capacity. 3. Decide on cache placement. Client-side cache, cached data stored locally on the user's device. Server-side cache, cached data stored on the application server or a centralized caching layer. Distributed cache, cached data shared across multiple nodes, e.g. Redis cluster, Hazelcast. CDN, cache static content closer to users for web applications. Tanner 4, choose an eviction policy. Popular policies least recently used, evict the least recently accessed items. LFU, least frequently used, evict items with the lowest access frequency. FIFO, first in, first out, evict the oldest items. Custom policy, design an eviction policy tailored to specific application needs. Considerations, trade-offs between complexity and performance, memory overhead for tracking access frequency or recency. 5. Determine the caching strategy. Read through cache. Cache sits between the application and the database. Data is automatically fetched from the database on a cache miss. Write through cache. Updates to the cache are immediately written to the underlying database. Write back cache. Updates are written to the cache first and asynchronously written to the database later. Cache aside, application explicitly manages data loading and eviction from the cache. 6. Define data expiration rules. Time to live. Set expiration times for cache data to ensure freshness. Dynamic TTL. Adjust TTL based on data type, usage patterns, or system load. Manual invalidation. Allow manual eviction of specific keys or datasets when data becomes stale. 7. Ensure scalability. Horizontal scaling. Use distributed caching systems to scale across multiple nodes, e.g. Redis cluster, Amazon Elasticache. Partitioning. Partition cache keys across nodes to distribute the load evenly. Replication. Replicate data across nodes for fault tolerance and high availability. 8. Handle consistency and synchronization. Cache consistency. Decide how to handle cache invalidation when underlying data changes. Cache coherence. Ensure distributed caches stay synchronized. Use techniques like versioning, pub subsystems, or cache invalidation messages. 9. Monitor and optimize. Track metrics. Monitor cache hit rate, miss rate, eviction rate, and latency. Optimize performance. Tune the size of the cache and adjust eviction policies based on usage patterns. Auto-scaling. Automatically scale cache capacity based on traffic demands. 10. Plan for failure and recovery. Graceful degradation. Ensure the application can still function, albeit slower, if the cache fails. Backup strategies. Regularly backup critical cache data for disaster recovery. Failover mechanisms. Use redundant cache nodes or clusters for fault tolerance. 11. Test the system. Functional testing. Ensure the cache stores, retrieves, and evicts data correctly. Performance testing. Simulate high traffic and measure latency, throughput, and scalability. Failure testing. Test the system's behavior under node failures or cache misses. 12. Deploy and maintain. Deploy incrementally. Start with a small cache size and expand based on performance needs. Monitor and iterate. Continuously monitor usage patterns and refine the caching strategy. Conclusion. By following these steps, you can design a robust caching system tailored to your application's performance and scalability needs. Careful consideration of eviction policies, data expiration, and scalability will ensure that the caching layer enhances user experience and optimizes resource utilization.